Envision an enormous orchestra played by a limitless number of stars, planets, and moons, all playing as a unified whole. Anyway, there is one specific area of this ensemble that has bewildered cosmologists for quite a long time: exoplanets. Exoplanets are normal planets that exist outside our planetary group, stowed away somewhere down in the smooth manner. You may be astonished to discover that among the tremendous number of astronomical items, there are exoplanets so like Earth. So, the story takes a surprising turn. Very much like in any sci-fi thrill ride, analysts utilizing the James Webb Space Telescope caught something remarkable from Proxima B, a sign so strange that it moved throughout the scholastic passageways and informal communities. Named as a potential technosignature, it was an electromagnetic emanation so complex and colossally designed that it could demonstrate the presence of an advanced civilization. The joint heartbeat of mankind appeared to stop at the peak of a disclosure that guaranteed to change our view of reality. Could the sign be the certain evidence that we are not alone in the universe? And similarly, as fast as it seemed, the signal vanished without rehashing itself, leaving behind not just an overpowering quietness, but also a labyrinth of unanswered inquiries and percolating hypotheses. Was it just a transient, inestimable peculiarity, an accident of grandiose arrangement, or something more intentional, a coded message, or even an indication of an unpleasant, inestimable quintessence? The lone mission cast the shadow of conundrum over Proxima B, starting extreme discussion and theory. Was it simply a passing irregularity, or is it part of an infinite account undeniably more perplexing than we can envision? However, wait, the account-embroidered artwork of our infinite investigation isn't complete. The ink has not yet dried, and new sections are still being composed. This time, it isn't simply standard researchers, but Harvard specialists who are driving a change in outlook in our search for extraterrestrial life. They are not intent on simply examining the signs and peculiarities we have examined up until this point. They are increasing the game by changing the James Webb Space Telescope into a kind of enormous night vision telescope. They want to look for artificial light sources in both the dim and enlightened areas of far-off universes. We're looking at faltering suggestions, for example, the chance of identifying earthly variants of urban areas sparkling in obscurity like radiant SPS. Envision seeing the brilliant shafts of what could be a city murmuring with the presence of a high-level progress, emanating its glow into the tremendous grandiose seas. We continue to unwind the secrets of the universe. The journey for extraterrestrial life takes on new aspects beyond the prompt interest of Proxima B. Our enormous hunt dives deeper into the huge, strange areas of space. This pursuit is driven by both innovative headways and a significant interest in our place in the universe. Ongoing advancements in cosmology and space investigation have led to the discovery of various exoplanets with potential livability. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories have extended our capacity to identify and investigate these far-off universes. One especially intriguing field of study is the quest for biosignatures, pointers of life. Biosignature marks could include climatic gases like methane or carbon dioxide, which, in the right circumstances, could suggest biological cycles. The JWST's capacities reach out past simple location. Its high-level instruments can measure the atmospheric composition of exoplanets with exceptional exactness. By investigating starlight that channels through an exoplanet's atmosphere, researchers can distinguish chemical marks characteristic of life. For example, the presence of water vapor, along with other key molecules such as oxygen or ozone, could indicate the potential for life-supporting conditions. One more road of investigation includes examining the environments of these far-off universes. Environment models, besides, the idea of technosignatures has acquired traction. These are signs of cutting-edge civilizations that may be discernible through artificial designs or advanced technology. This could include megastructures like Dyson spheres, hypothetical constructs intended to capture a star's energy, or unusual patterns in radio transmissions. As we move along our observational procedures, the hunt for technosignatures could uncover the presence of extraterrestrial intelligence. Notwithstanding innovative progressions, global joint efforts are vital in the search for extraterrestrial life. Organizations between space agencies, research institutions, and private associations enhance our capacity to explore space. For example, missions to Mars and other celestial bodies include contributions from various nations pooling resources and expertise to achieve shared goals. Public engagement and education play fundamental roles in this journey, and the excitement surrounding space exploration motivates the future of researchers and specialists. Outreach programs and educational drives help to foster an interest in STEM fields and encourage youngsters to pursue careers in space science. The advancement of new technologies also adds to how we might understand the universe. Advancements in telescope design, data processing, and computational models improve our capacity to detect and analyze far-off exoplanets. For example, cutting-edge space telescopes, such as the planned Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HabEx, vow to offer even more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the limits of our knowledge, every discovery prompts new inquiries and areas for exploration. The quest for extraterrestrial life isn't just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our perception and expands our understanding of what it means to be alive. In summary, the exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each advancement, we edge closer to answering some of the most significant questions humanity has ever asked. As we continue to explore the universe, the possibilities for finding new forms of life and understanding our place in the cosmos remain endless. Tantalizingly similar yet perplexing, it very well may be our planet's divine twin. We dig into the entrancing domain of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is altering our quest for and understanding of these celestial puzzlers. Envision a moment when your mind travels across the immense cosmic domain of our system, the smooth way which is home to more than a quadrillion exoplanets. That's one followed by 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon. We would have enough to create another landmark on Earth, a Grand Canyon 2.0 that would stretch for a significant distance. What is most astonishing is that around 20% of these celestial bodies have been deemed Earth-like in terms of geographical and environmental design. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rocky satellites like our moon, locked in gravitational dances with their parent planets. If you were to consider finding another body in space that harbors life, or could do so, the universe offers an overflow of opportunities. Now that we have unfurled the material of vast scope, it's time to present the master craftsman prepared to paint its intricate details. The James Webb Space Telescope. This divine Sherlock Holmes, with its magnificent focal length supplanted by adjustable lenses, surpasses even the most advanced Marfan optics. We're not talking about any lens. It's 6.5 meters in primary mirrors, 2.7 times bigger than Hubble's. Envision the best detail it can identify, even in the slightest glimmer of a star billions of light-years away, and then analyze the details of orbiting planets. What makes the James Webb Telescope revolutionary isn't just its observing power but also its advanced technology, including forward sensors and spectrographs. These instruments can do much more than observe. They can analyze and filter the unique light signatures radiated or reflected by celestial objects to unravel their atmospheric conditions, composition, density, and even mass. Acting as a space detective, they can determine if a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the capacity to answer these questions, raising it from a mere observer to an analytical genius. It's not only an advance over its predecessor, Hubble. It's more like a quantum leap. If Hubble's discoveries amazed you, prepare for a genuine explosion of celestial revelations. Similarly, as we expand our view across the intricate landscape of the universe, it's worth focusing on one specific star in the cosmic show, Proxima B. Since its discovery in 2016, this mysterious planet has stood out as a Shakespearean hero, filled with complexity and enigmas, captivating astronomers and astrobiologists alike. What's the fuss all about? First of all, Proxima B is essentially in our cosmic neighborhood, just 4.2 light-years from Earth. To put it in context, if you could surpass the universal speed limit and travel at the speed of light, you would arrive in a little over 4 years, about the same amount of time it takes for your favorite television show to fall into reruns. But let's delve deeper into why this proximity is so significant. We're talking about a universe that extends more than 93 billion light-years from one end to another, so finding a planet so close and so promising for scientific research is like finding a gem in a pile the size of Mount Everest. A gem that possibly holds secrets about life itself in the grand woven fabric of the universe. Proxima B is a multifaceted line offering us priceless hints that could redefine how we might understand habitability and life beyond Earth. It's not just Proxima B's proximity to Earth that excites mainstream scientists, but also the tantalizing signals that this planet isn't just Earth-like, but perhaps Earth 2.0. Proxima B sits serenely in what space experts call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, wandering waterways, immense lakes, and maybe even seas as deep and mysterious as the Mariana Trench. Yet, before we start dreaming about traveling to Proxima B, we need to consider some of the idiosyncrasies. For instance, a single day on this intriguing exoplanet lasts a staggering 11 days. Imagine sunsets that not only herald another day but unfold slowly, resisting giving way to noon and sunsets that stretch, creating brilliant hours that photographers long for. While it sounds idyllic, it also has significant implications for its environment and habitability. How might human biorhythms adjust to the patterns of light and dark on Proxima B? Would we need to eat 3 or 4 times more in a single day on that planet? Would we sleep the same way on this entirely different world? The key aspects of life as we know it would be immediately tantalizingly similar and, unfortunately, abnormal. It is as though nature is presenting us with a puzzle wrapped in a conundrum, challenging our understanding of what makes a planet habitable. You might wonder how we can acquire precise and reliable information about a world we have never visited. The James Webb Space Telescope brings all its capabilities like a vast Swiss Army knife. It's more than just a telescope. It is a sophisticated research lab in the vacuum of space. Thanks to its innovative technology, space experts can not only observe planets but also examine them through a prism of scientific instruments that would make CSI labs look simple. Utilizing advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Every element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, researchers can perform a distant biopsy of celestial bodies, determining not just air pressure and density, but also the possible presence of compounds essential for life, such as water, organic carbon molecules, and even oxygen. It's not just cosmology, it's space forensic science. We don't passively wait for clues to come to us. We actively seek them out, investigating the atoms and molecules that make up these complex universes. The Webb telescope is not merely an eye in the sky. It's a highly specialized laboratory, investigator, and cosmic analyst all in one. It allows us to turn our theories and speculations about alien worlds into strategies to confirm or refute them, revolutionizing our understanding of what could exist beyond our blue dot. Right when you thought you had unveiled the most shocking layers of this vast cosmic tapestry, the adventure is just beginning.